Good afternoon, everyone, and welcome to today's sponsored webinar, Bristola's patented tank entry technology. Save time, save money, save lives. My name is Bailey Shore, and I will be facilitating this webinar. But before we begin, I want to thank Bristola for sponsoring today's webinar. Their sponsorship directly supports the ABC and our programs. Couple quick notes before we start with the content, just a bit of housekeeping. You should already be able to hear me and see the slide titled Quick Notes. If you're hearing echoes or your sound quality is bad, change the audio options in the GoToWebinar toolbar, which should be on the right side of your screen. If you're still having trouble, send the organizers a message using the questions section of the toolbar. And don't worry, we are also recording this webinar and we will send you both the recording and slides tomorrow. If you have any questions, we encourage you to ask them at any time using that questions pod in the toolbar, and we will handle all questions at the end of today's presentation with a short Q&A. It's great to see so many ABC members on the line, and thank you for your continued support to make all that we do possible. For those of you that aren't members yet, we're also thrilled to have you. In case you're not familiar with the American Biogas Council, we are the voice of the U.S. biogas industry. We represent about 330 organizations, which reflect the entire American biogas industry. If you're not a member and you'd like to engage with us and help us grow the biogas industry and your business, please join the ABC through our website, americanbiogascouncil.org. Now, before we get started, I'd like to give you a brief overview of today's webinar and our speakers. An average of 100 confined space-related deaths occur each year in workplaces in the United States. Bristola's CEO and founder, Jared Burma, had a personal near-death experience working in confined spaces, which has resulted in him dedicating his company's resources and research to establishing confined space cleaning processes that eliminate human exposure hours while increasing the likelihood of a more functional system for the end user. This near-death experience led Jared and his company to develop a cleaning system which sends a remote-controlled robot through a patented entrance system directly into a confined space for cleaning and maintenance. The SRCS allows the cleaning and inspection of tanks and covered lagoons without disruptions to their operational system. By utilizing Bristola's patented SRCS cleaning and inspecting technology, digester tanks will become more efficient and cost-effective, giving way to better utilization of actual storage processing, which will improve the overall operation and long-term deployment of these facilities. The SRCS installs on new and existing tanks and lagoons and operates while tanks and lagoons remain in operation. With this proprietary technology, no human entry is required, and the overall optimal capacity is maintained. With no disruption in operations, there are significant environmental benefits as well because there is no release of methane gas during the tank facility cleaning and maintenance. During this webinar, participants will learn more about this technology and see an actual deployment demonstration, and you can learn more at bristola2.com. Now let's learn a little bit about our speakers. We have Jared Burma, who's the CEO. Jared possesses a degree from Simpson College and has developed the SRCS technology based on his 20 years industry expertise and understanding. In his role as CEO, Jared has worked to develop and test the technology, build a market and sales strategy, implement the marketing and sales of the technology, and establish key business relationships in the US and abroad. We also have Ian Dunlap, who is the Chief Technology Officer, and Ian possesses a degree from Clarion University and over 10 years of experience serving as an engineer and technology development in the oil and gas and robotics industries. Ian has specialized experience in CAD, programming CNC machines, designing and developing prototypes for operations, and implementing new technologies into operational service. Ian has played an integral role in designing and testing the Bristola patented entry system and SRCS and is continuously working on continued system improvements. Feel free to submit questions during the webinar. Questions will be answered at the end with a brief Q&A session. All questions and comments will be recorded, and a recording of the webinar and slides will be available by March 10th to all ABC members and all attendees of this webinar. So thank you all for joining us. And without further ado, I will hand it off to our speakers for the day, Jared and Ian with Bristola, to lead you through this great presentation. Jared and Ian, feel free to take it away.
Thank you, Bailey. I appreciate it. I appreciate everything the ABC has done. We welcome this opportunity to take the time to explain what we're going through today, what our technology is, how it works, and all that stuff. As Bailey said, my name is Jared Burma, CEO, owner of Bristola. I have with me today our brains behind the operation, Ian Dunlap, CTO, Chief Technology Officer of Bristola. Ian's tasked with a lot of short deadlines and crazy ideas that I write down on paper and ask him to make come to fruition. So today, what we're going to do is we're going to give you an introduction of Bristola, a little overview of who we are and what we do. Then we're going to talk through some industry dynamics and work through the technology. You know, why everybody's here. You guys want to see the robot and the technology working. So without further ado, we'll get started with our PowerPoint. We'll go ahead to the next slide here. Go ahead to the next slide. Yep. So as we said, we're going to give you an introduction, talk about who we are, industry dynamics, technology, and then give you guys a little ROI on a digester project we worked with in the past. So as Bailey was mentioning, in 2017, we were cleaning the anaerobic digester out for a city municipality. It had 20 foot of sediment in it. We were there working. Water had worked its way to the back side of that wall. As we augured our way to the bottom and got down on the floor, made a big path, the sediment wall decided it was going to break loose. I was unaware of the water that had been moved over to the back side of that wall. We were 30 foot below ground. You know, we had lanyards and all the safety retrieval stuff on. The guy we were working with, I was training. As that stuff started to come down, I told him to get up the ladder. His lanyard had wrapped around the bottom of the ladder. As this stuff was racing towards us, you know, I had to reach down, unhook his lanyard. As I made it up that ladder, the sediment and the liquid hit me in the back of the legs, ruined all of our monitors, all of our gas monitors, everything were going off, make a big release of liquid that came out of there. So with that, I said, you know, there's got to be a better way. I spent a couple years working with engineers in the anaerobic digester world, the tank world, just trying to figure out, you know, what's the best way to make this happen. So, you know, that brings us into, you know, the industry overview. As Bristola in the last couple of years, you know, as everybody's on this call today, majority of you are in the anaerobic, you know, digester world. It's a very hot topic right now. Everybody wants in it. So that's where we've really dedicated our time and our effort and our technology to as of today. However, you know, we know that this is usable, and we'll walk through some of the technology advantages we can use in different scenarios. But the, you know, the call today is to basically speak to the anaerobic digester world, show them why, you know, this works, why it was created, and how it's designed. And knowing that that's our phase one, we're going to work towards, you know, our phase four. A couple years down the road, we'll be getting into the more oil and gas chemical tank cleanings online. We have a few things to jump through, hoops to get worked out on things like that. But, you know, the robots can do so many more things than just anaerobic digester cleaning. So as we walk through this today, just kind of keep that in mind. And, you know, without further ado, why everybody's here today, Ian and I are going to walk through the technology portion of this. So now we're going to go to live, you know, web, and we're going to discuss how everything lays out, how it works, what role it plays, and making this, you know, operation successful. We're going to start. Ian, you want to work with me over here? Yes. Just a second. We'll get over to there. Go ahead and pan to our side over here, please. So this is the Bristola entry port. You can zoom in a little bit on this, and this is what the only thing that the client has to purchase. This valve right here gives us the access to your tank. When this gets purchased, basically we can adapt to any hole that's out there, whether it be a square hole, round hole. All we need, Ian, correct me if I'm wrong, is 24-inch diameter at the minimum.
Yes, correct. Minimum 24 inches. 24. We can go all the way up.
Yep.
However big it is.
Yeah, we've had a lot of questions on, you know, can you adapt to this? Can you do this? Can you do that? This is the gate valve. What we do for the clients, a lot of engineers ask, hey, that's a lot of weight. in here. What we do, we have a custom patented a stand that bolts right into this bolt holes right here that'll go down to the ground, takes all the weight off your tank. So we will not add any additional weight to the tank itself. All right. So that's one piece of the puzzle. The other piece of the puzzle that had to be created to make this operation work was basically a buoyant, self-buoyant hose that was regulated on the outside that created a float behind the robot so the robot doesn't back up over itself. We created this hose with custom patent ends that will allow us to clamp the hose on the outside, but allows solids and fluid to transfer on the inside. It also allows us to regulate the pressure. As we get into different materials, water, manure, whatever it might be, we need to add or subtract PSIs to get this to float properly. This is also critical in helping us seal our chamber that we'll work into next. But what makes this work, it allows our power cables to come out. I'm not sure if you guys can see that or not, but everything is contained within this umbilical cord here itself. Nothing else like it on the market. There's actual multiple industries we can, deploy this into. It allows you to get away from floating buoys or buoys that catch on things. This is a kind of a bear to create, but it's worth its weight in gold once it's created. Moving on, we're gonna go ahead and show you our entry box. And as I show you the entry box, I'll talk about it a little bit, but we'll show you then we're gonna actually deploy the robot out, drop the robot on the ground, and do a function test with the robot. That'll give you guys a little understanding of how the robot works, what it does, how it does. So when we come to a client's facility and they have this entry valve already installed, it's as simple as lining this up, getting the bolts into these holes, and it's all sealed. As it's sealed, the robot is then placed through the top. The panel's off for demonstration purposes. The robot is placed in the top of the box. All function tests, everything's done. There's a full winch, that's submersible winch inside of this box that moves with the arm. There's a additional unit on the back. As we get over to the back of this machine, we'll show you what we call our hose mover that helps move this hose in and out. Now, these are our control panels, one for the box and one for the robot. They can be basically placed anywhere on the site. You'll see it when we pan over this direction, but right now we use a Connex box outfitted with air conditioned heat, full display cameras, everything. All these boxes would be inside of there. Now, if a client wished or we didn't have the access to get that box to there, we can take these out and place them anywhere. We also created an individual panel that a guy can walk right up, hook up to there, and now have his own joysticks in his hand and be maneuverable. So we not only have in-place controls, we have mobile control units. So as Ian's going to run this for us, I'm going to talk about what it's doing as it's coming out. You're going to get to see it, come out, hit the ground, turn left, turn right, turn auger on. I'll talk about some of the technology that's on our submersible. The robot that's going to be coming out is our RoboGar 245, 24-inch diameter, 5 horsepower motor. It will do 300 gallons per minute between 5 and 8% solids. So why that's important is we have to have the ability to keep this running all the time. Ian, without further ado, let's show them.
Yeah, so we're gonna deploy the robot now and drop it down to the ground.
So what you can't see, we are not all the way deployed. We're not going to deploy it for lack of room inside of our R&D facility here in Houston. There is LED sensors, lights on here with positioning sensors for the robot that tells us when it's all the way in home position, tells us when it's all the way on the ground or heavy enough sediment to trip that sensor. There's a position sensor that tells us when it's all the way in home base. All that data reading is coming back to the controllers here. So we know when it's all the way in, all the way out, all the way up, all the way down. That's the brains behind the operation of, when you're running into a tank blind, you have to have that technology readily available for you. Ian was going to go ahead and drop it to the ground. So now when we get it all the way to the ground, there's a sensor that's on the robot that tells us, hey, you're on something hard. You know, it could be sediment, which is fine. Sediment is no problem for this. It'll work itself to the ground, but it gives us a level of, hey, how far down did this travel before we hit something solid, so we know where we're at within the tank. Now, when we're in the tank, we also have what we call our side scan sonar. This is going to put out a sonar, you know, basically 180, is it 180?
180 degrees.
180 degrees. This is communicating back with our screens inside of our Connex box. And a lot of people are like, well, it's in manure. You're not going to get that great a picture with the sonar. And they're 100% right. It's not a fish finder sonar. It is a sonar that's going to be constantly orange. When you hit steel or something solid, it will give you a little bit change of color to a darker red. Our operators are trained to know where they're at with that. Not to mention, each time we deploy this robot, we know how many feet in we are from our hose, how many feet in we are from our cable. It has a distance tracking mechanism on the cable. It tells you how much is in, how much is out. We don't just drive haphazardly around the tank. It goes in, it goes down, it goes, works its vacuums or pumps its way in 10 feet, and then it works all the way left and all the way right, and then we continue 10 feet in again. If there's a center post agitators or whatever those look like, we aren't going to go directly into those or make hard 90-degree corners or anything like that. There is certain limitations. However, we have only minimal occasion found tanks that we couldn't clean out. But we're very open and know our limitations. Our goal is to not stick this in your tank. We haven't had any problems as of today, but there is a safety retrieval cable rated for 10,000 pounds. This robot weighs 300, so we can pull a lot. Not to mention, this hose has an extremely well pulling tension, so you can pull a lot of weight back with this. So you really have to get it snagged on something extremely hard. But by reading blueprints, operator trainers, side scan sonar, and finally, but last but not least, is our positioning sensor. So this is a positioning sonar. It is not GPS. That is not readily available to the public as of today. But that positioning sensor with some outside sensors will give us relative position in your tank within 3 feet. Now, is it perfect? No. But it will give us a good idea of where we're at. Are we all the way left or are we all the way right, or vice versa? It's going to let us know that. It's not going to say, hey, you're 17 inches from the wall at 34 degrees. It's not that technical. It's a relative position. So our overall goal with this robot is to get you majority clean. We never tell our clients that you're going to get 100% clean. That is not our goal, not our intention, not our selling point. This is to get a lot of sediment out in a hurry while you're online, while you're making gas. Ian, go ahead and let's show them a little bit of drive, left, right, and then we'll get it turned so it's facing the camera and we can run the auger. Yep.
Put a little
And
more
so,
hose out.
yeah, we got a hose feeder that kind of feeds the hose out as we go, and then you can just back it up and turn. There you go. So with that, I'll just have him go ahead. This is the auger. You can see it's a slow, high torque auger. It's not gonna make a lot of agitation in your tank. It's just gonna, basically work its way around. If it's really, really hard sediment, we have the ability to add our 7,000 psi at 8 gallons per minute power wash jet nozzles as well. We were just on a project where we needed that to get a little more breakup besides what the auger can do. Go ahead, turn the auger on. You see the auger, it's a forward auger and a reverse auger. A lot of people have asked, how does that handle strings, tampons, rags, or municipality material? What I tell people, it is a stringy material. Obviously, we'll get wrapped up around that. Not gonna sugarcoat it. That is gonna happen. The good thing about this is we can bring this up, get it out. We can also still do a lot as the auger, if it's not working properly. So if we go into a tank and then within 2 hours the auger's plugged and it happens multiple times, we'll probably add the power wash jets, bypass the auger, and just still pumping. We have passed up to 6-inch wrench through this pump, 3-inch rocks through this pump, rubber hoof guards through this pump, skulls, bones, dang near anything you can imagine. So if we can get it to this pump, we can get it out of the digester. Everybody says, how thick of stuff can you move? Great thing about this is we get head pressure going in from the bottom to help move solids out the door. We can move a lot of solids out the door. We've had a lot of client testimony. A lot of people witness that. It looks little, but it's what I tell everybody. It's mighty. It'll move a lot of solids using a lot of liquid, head pressure, pump right here, agitation, power jets if needed. Moving on, we also have what we call our Big Bertha. This is a 36-inch robot, 10 horsepower motor, 600 gallons per minute, 10% solids, best case scenario, maybe 8 to 10% solids in there.
Actually gonna be closer to 700 gallons per minute.
700 gallons per minute, 8 percent solids. And everybody's saying, yeah, that sounds great. You say that percent solids. How do you really know that? I've been in the industry a long time. I hate taking samples and waiting 24, 48, however many hours to get a percent solids test back. So in line of this hose, we run a real-time percent solids meter. Data's directly into that cab. Our operators know when they're in good material, bad material, if it's real thin, real thick, is it too thin, is it too thick, and that helps us know where the robot needs to go. It needs to keep moving forward, or hey, it's getting so thick, we need to back up and move some liquid through it. Percent solids meter is an absolute game changer for the robots. We also use a flow meter, a real-time flow meter. All this data and analytics going into the cab real time. The guys can say, oh my gosh, we're down to 100 gallons per minute. We must be getting plugged up. Let's back up, let it flush out, something like that. These two pieces work awesome with the robot world. It just makes things so much easier, especially when you're blind. Ian's good enough to run a robot basically with his eyes closed on an open top tank. But when we got into the blind tank, where we're going in at the bottom, we had to have this information, not an hour from now, not 5 minutes from now, but in real time. Otherwise, you're wasting a lot of time. Are we in good stuff? Are we not in good stuff? Blah, blah, blah. Long answers. Finally, we also have been running into a lot lately where people needed dry material moved. So all of our robots are interchangeable with vac bodies. We can hook up to any vacuum truck out there in the country, take the guy out the end of the hose, dragging the hose, back braking work, put the vac body on with a pan tilt zoom camera. You can inspect and vac at the same time, and you can put it right on this robot. Hook your vac hose up to it. We have vac wheel hose movers that go on the hose that helps it move across the ground. May need them, may not need them. You can add different things. You can add a power wash nozzles to here, different things, different solutions for different materials, I guess I would say. Ian, did I miss anything on what we just discussed on these materials here?
You covered a lot of our capabilities. The only thing I would say is, as well as on the vacuum, you can also attach an auger brush. Once again, on line tanks, we can go with softer, head attachments so that we can protect those assets as well.
Yeah, and that brings up a great point. We've had a lot of people say, "Oh, what about HTP line lagoons or line tanks?" We just successfully did a line lagoon out in New Mexico. These things work awesome on them. Very, very easy on the lagoon. We came out and helped a client find some tears in the lagoon that was caused by a big dredge. So these things have a multi-purpose. You can use them for a lot of different things. Rubber tracks, very easy on your HTP liners. No issues there. All this is very modular. You can be, if something breaks on one of these things, we take it out. You can put a whole new track assembly on an hour, and you're back online, running, up and running. Panning this way a little bit, you're going to be able to see, this is a Connex that we have. Obviously, we have limited visibility here with the setup and what we're doing. But basically, it's a heated and cooled Connex facility with our screens and monitors in there that are getting this real-time data directly fed into them. This is more of the entry box that you can see. These are the brains behind holding the pressure, allowing the hose to move in and out, and not letting liquid get to the outside. This is a custom built patented hose mover that we put on this patented entry box system to basically eliminate all guys having to help feed hose and or pull hose back out. Works extremely well, takes a lot of weight. our guys are pretty happy we added that to this box, don't you think, Ian?
Yeah, we made a lot of improvements over the last couple months, and we're continuously making improvements.
Yeah. No, I mean, and there's just a lot, these are self-leveling. A lot of people said, hey, we got a valve up 20 foot off the ground. Can you get attached to it? We have a lot of different options. We either add longer legs, build up the stand that it's going to stand on. These crank down, self level this box, so it's a level attachment to your tank. Doesn't add any weight to your tank. Very very user friendly. Um, we went to all variable drive motors. Everything can be turned up, turned down. They're all talking to each other. They're running very, inter, interconnected is I guess the word I'm looking for. We spent a lot of time working those kinks out of the system, making sure, before it was, 4 guys to run this. One guy's running the hose, one guy's running the robot. So, we've really brought this a long ways. That's why we were excited today that ABC was allowing us this time to, basically showcase these different things. What you don't see here today is also a pitched track robot. We are doing pipe cleaning, 24-inch or larger diameter pipe cleaning. We're cutting that down for the client from a 2-step process where they have to clean the pipe and then video inspect the pipe to now they can clean and video inspect all in one. With our pan tilt underwater camera, you can zoom in, check your pipes out, and be vacuuming or pumping the sediment out as you go. Time is money. So if you can cut a process out, that they're ecstatic about it. And we're hitting the road next week to go showcase these out in some other states and across the United States, and going to end on a nice project up in Vermont. So with that, I think I hit majority of everything. We want to leave a lot of time for questions and answers. We understand that there's going to be a lot of questions. Hopefully we've hit some. What we're going to do now is we're going to run through a few more questions that we frequently get to try to mitigate the question answer phase or just help people kind of understand what we're doing, how we're doing it. I think the biggest question that we get today, and hopefully this will answer just by visually seeing it, is what's your footprint? Oh, that's a great question. You're looking at the entry box is about 18 foot overall. Attached to that tank, you need to have 18 foot of space. Now there's different ways that you can do that. A lot of guys are like, well, I have 2 digesters and the manholes are right beside each other. Well, that's tough. I can't get to those. Now, if they're out at a 45, absolutely we can get to those. So, we have to look at each facility individually. The biggest thing that we don't have the room to get this in here is a lot of people well, what do you do with the sediment? Well, that was great. That's a great question. And do you want to talk about what do we do with the sediment?
Yeah, so there are a lot of different options, but we have a patented system. It's a very low footprint. It comes on a 53-foot trailer. It's going to take everything. It's going to start with removing all your big debris. It can put that in a dumpster. It's going to start with a couple different systems that are going to remove from your larger to your smaller solids, and it's going to convey out to the side. It can go into a dump truck, a roll-off, into a pile. You can hit it with a little skid steer and load it, somewhere else on your facility.
Yeah, and so what that allows us to do is we have to keep these running. If we're waiting on a dewatering box, you got to have 100 of them to keep up with what we're doing. If you're putting a centrifuge or a belt presses, you're basically taking the cost to an astronomical level. We needed to find something right in the middle that keeps these guys running, but also gets the sediment out in a very timely manner. No polymer, no chemicals, rapid deployment, fully mobile. 2 guys set it up, a couple hours, we're on the road, we're moving. So that has, that's a 53-foot semi-trailer with the conveyors that will come off the side. So that gives you an idea of the footprint. Now everybody's like, well, we can't get that semi-trailer that close to this tank. That's great. We don't need it that close to the tank. We can add 2, 3, 7, 100 different booster pumps and get it to as far away as you need it to get it to. Obviously, there comes a point as economics have an issue with that. As we add pumps, it gets more expensive. But we can get it to wherever you have room for your, for solids removal. So that's the beautiful thing about it is it's mobile. It comes in on a semi, put it where you want, goes out on a semi, put it, take it out quickly. Those are really the 2 real big questions we get. I hope I answered some questions when I said, all we need is 24-inch diameter. If it's a square, we've adapted to a skid loader, 8x10 drive-through, system. We will basically bring it down to that. But at any time you want to get back to your skid loader, we're not taking that ability away from you, or your 4x4 manhole or whatever that is. This is just an additional piece. It doesn't actually change anything your tank's doing, or the structure of your tank. It's just an additional piece. Only thing that you own. The blind, comes with a blind flange cover that goes over that gate valve, so you're double protected from any leaks or any issues like that. We also put a insulated blanket, that's a removable, nice, professional-looking blanket to keep the heat and to protect it from the weather. All included. We come out, we do the full install. The seals, bolts are all included. Um, as far as the robot, that one's 250 pounds.
That one's about 230 pounds, and this one right here with that big pump, it's about 400 pounds.
400 pounds. So the next competitor in this realm would be a hydraulic robot, and they weigh what?
They weigh upwards of 1,000 pounds.
Upwards of 1,000 pounds. I'm not sure that they're fully submersible.
No.
We can go down 200 feet, fully submerged on 200 foot of head pressure. So a lot of really intricate, unique parts about this. A lot of patents issued on this material out here. We're really excited about it. We hope that our clients get really excited about it. Because if we can save one life, it really is worth the money.
It's worth it.
Yeah, absolutely. I mean, and that's what I tell our guys that are running this is, we may be a little slower. Economically, we may be a little more expensive. We may not be if you take all the costs into consideration. But at the end of the day, the client's running, the client's operating. You guys have no shutdown. You don't really care how long we're there, because we're only charging sediment removed in a digester, an entry system digester removal project, sediment removed. We're not charging you to take a bunch of liquid out. So, everybody, the response today have been really welcome. We've had a lot of people give certain kinds of pushback, or skepticism. So that's, how this came about. Hopefully we've, answered those questions, and presented to you guys a lot of the things that you wanted to know, wanted to see, wanted to hear. But at the end of the day, we're not done. This is what we call our Generation 1 robots. We have already started here in Houston in our R&D facility on our Generation 2 robots, with the goal to be fully autonomous soon. Stay tuned. So we're working through that. So building our relationships now with clients, making them understand, that helps everybody know where they're at and what's coming down the pipeline. So, I guess that should answer some of your questions. The last one, what can we use this on? You can do this also. We don't have it in here, it's too big, but a full covered lagoon entry system. We could get you materials on that. But basically that allows us to be underneath your liquid line, underneath your cover, without any interruptions, to your liner, open it up under anything. And we can deploy this robot into your covered lagoon. Allows the client to set their own budget. Instead of opening a tarp, you got to clean the entire thing out because it's open to the air, open to this atmosphere. So there's just a lot of things that Bristola is doing that we're bringing to the market. We've touched on a few today. Hopefully you guys have questions, comments. I know we have a survey going out at the end, that's going to ask you some of that stuff. There'll be a PowerPoint presentation that's going to send out at the end. In our emails, our contacts are on there. Feel free to reach out with any questions, comments, concerns. And then finally, the last piece that we did do recently, a lot of clients asked this, Ian, was, what's our return on investment? So that's a really tricky question. Depends on, what your digester style is, what feedstock you have, how much you're selling your gas for, all these different things. However, we said, okay, we're going to take a shot in the dark and figure this out on a sand bedded dairy in Wisconsin, complete mix digester, 1.2 million gallon tank. We did all the math, all the inputs, what it costs for traditional cleaning, what you're losing in space, retention, gas production, maintenance hours, all that stuff from the heaviness of the sand, wearing out pumps and bearings, and then from our system. The numbers we got, and this will be in the PowerPoint that comes out to you guys, we show $147,000 return on your investment annually per digester. I mean, basically we're paying for your digester. You know, that in 5 years, that's 750 some $1,000. I don't have the math in front of me right now, but I know it because I've had to speak on it multiple times. But one digester, $147,000 a year. You know, that's selling gas at $28 in MMBTU. I know for a fact majority of you on the call today are selling your gas much more than that. And if you have long-term offtakes and you're at 22, we can, you know, you can work that backwards in the ROI that we've provided. Again, those are assumptions. Those are using calculations of a certain farm. There may be other industries that you may not have that same ROI. But as I always come back to, you can't put a value on a human life. And I've physically been in that situation, you know, where my life was almost taken inside of a digester. So if somebody says, well, you know, we don't have that much sediment, or we don't have that kind of value for our end product, my simple question is, you know, what value do you put on somebody going in there and cleaning it out and getting injured, or worst case scenario, dying? You know, let's get rid of that. Let's change the narrative, change the community of digester cleaning, tank cleaning in general. And that's why we're here today. Ian, anything I miss? I talk a lot, guys. I'm sorry. I go fast. Hopefully you have any time for questions, but Ian, touch on anything I missed.
The biggest thing I would say is, I mean, here's a you know, a good snapshot of our equipment here. You know, kind of the scope we're working. We have a lot of others. If your site has another application, hydrolyzers, don't be afraid to ask us or ask our sales team.
Yeah, yeah, that's a great point. I mean, we're working with oil field people. We're working with water treatment facilities. You know, these are slow agitation, so you're not going to stir up a bunch of sediment and contaminate your good water. Cooling towers, online cleaning. I mean, where do you stop? We can go on and on.
Yeah,
and on.
there's a lot.
Yeah, there's a lot of opportunities for these robots to be utilized. Basically, we consider ourselves a yes company. You call us and ask us to figure out a project. That's what Ian and I really love to do. I have a great team here at Bristola. This stuff is what, you know, the everyday stuff, cleaning out tanks that we've already done. We consider that our easy stuff. We love new challenges. Come to us, ask us, say, hey, this is valuable to me. We need to come up with a solution. We will. With that, I think Bailey is going to narrate some question and answers for us. If anybody has any questions now, if not, you know, I appreciate all the time. I know everybody's busy, and hopefully we answered everything you have.
Yeah, Jared, we have a couple questions in the queue. Can you hear me okay?
Yes,
Let's just
we
make
can
sure
hear
they
you.
can hear us. These are great questions. All right, so the first one up is, hello, Jared. Sometimes our tanks are buried
Tilt the
up
camera up.
to 10 feet. How close does the Bristola valve need to be to get to the bottom of the tank?
Great question. Beautiful thing is that winch has 300 feet of cable on it. We can lower to 300 feet below ground level. So there's really not a floor out there. I don't think, I shouldn't say it, there isn't, but shouldn't be a floor 300 feet below your manhole. So we just did a floor for a municipality that was 30 foot below grade. So 10 foot, slam dunk. Yeah, no problem.
Awesome. Our next question is, can an existing 24-inch stainless steel knife gate valve be used?
No, that's a great question. That is not a possibility as of today. What we do is we change our bolt pattern on our gate valve. Simply, you know, we've got a lot of time and money and energy into this. We don't want it being replicated. So anybody can go put a 24-inch valve on. However, that box will not hook up to it. You know, and we have patented the method of entry, the method of you know, getting that robot in and out of that tank through that gate valve. So all we would ask is, you know, we got a lot of time, money, engineering, you know, to work with us on that gate valve. If you have one and the tank's already full, we could talk about that. But if somebody's building tanks and adding gate valves, we're going to have a problem with that. Obviously, that's taking away from what Bristola's created, and our box will not hook up to your gate valve.
All right, the next question is a multi, a couple of questions in one. So I'm going to read the whole thing and you let me know if you need me to repeat any of it, okay?
Yes.
First piece, how does your system connect to a covered lagoon? In a covered lagoon scenario, do you lose the advantage of head pressure given that you would probably enter through some type of hatch or port retrofitted to the cover? And then there's a second part after you answer that first part.
All right, great question. Yes, so An existing cover lagoon, you have to basically make some entries into your cover, and we re-weld it back. But we go in at our pipe is going to be 8 foot below freeboard, so 6 foot below the top of your water liquid line. So when we go in and we go down, yes, we are going to lose some head pressure because we are working at above, above the bottom of the digester. However, we still have the 6 foot of head pressure, whereas a dredge sits at the top and has zero head pressure. We still have an advantage. We also can then use our big robot that has zero problem moving liquid up and or with little to zero head pressure, because we're doing open top tanks from the top now. That's no head pressure, where we don't get any head pressure advantage from that.
Exactly.
Yeah. So that's kind of the answer to that question. It's a patented entry system that goes in your lagoon. Definitely, every lagoon's different. Every liner's different. Everything is different. We use a subcontractor certified HDPE welder to get everything welded back, test it all, proven out, and we can then come and deploy on the outside of your liner and get our robot into the tank. If it's something you'd like to explore, obviously it's not a cookie cutter system. We have our standard system, but it still has to go through an engineering phase. So you can contact our sales guys and we can work you through that phase. And we can get you a lot more materials that you can look at, feel, touch. We have 2 different entry systems for a cover lagoon that you can look at and kind of understand. So second part of that.
Awesome. Second part is, have you ever been involved in the design and construction of a lagoon for entry from the bottom through a pipe opening built into the sidewall of the lagoon?
Yeah, that's our patented entry system. We have our own patented floor, lagoon, and entry system. That sounds exactly like what we have on file with the patent office. I don't know exactly what you're asking, but yes, that's exactly what we do. We have our own lagoon design. However, we can go into a different lagoon design as well, and it would be a hole into the liner that deploys our robot through that system. That's correct.
Great. And we have a couple more questions here, but I just want to let the attendees know, if you do have questions that you want to drop in the question bar on your toolbar for GoToWebinar. So a couple other questions. Can you clarify the operating conditions you need for a tank cleaning with robot? Ambient temp, no mixing, etc.
Yep, temperature wouldn't matter. I'm guessing you're working in mesophilic temperature. If you're working in thermophilic, I don't know if there's any out there in the United States today, but that's a pretty much, I think it's like 160 degrees Fahrenheit, I believe. That's going to get a little warm. It's fine. I don't, as far as agitators, what we ask the client to do, complete mixed agitators, if you're located at 3, 4, and 9, and 6 or something like that, when we're by number 6 that's on the clock or whatever, that agitator, we're going to have that agitator off. The other agitators can be running. When we exit for the evening, you can turn that agitator back on. And what we found is when you turn that agitator back on, it helps move sediment back to areas we've already cleaned. So we can't run around moving agitators, but remember, we're only working a certain area at a time. So as we work that area, that agitator's off, the rest of the agitators can be moving. Temperature, I think we would be comfortable up to 160 degrees.
Yeah, 160 is about the cutoff. If we can go past that, it's a couple engineering changes.
Awesome. Do you have any dairy references?
Yeah, we have multiple dairy references. We would just ask you guys get with us, and a lot of the clients that we work with, we have NDAs with, so we can't just disclose those out to the public. Again, why I didn't tell you who the clients were we've been working with in the past. Everything is top secret, but we can definitely get you references upon further discussion internally, and we've worked with the biggest digester facilities in the United States, so we're very comfortable with sharing those with permission from them, and permission on depending on who's requesting that information. So shoot us an email, whatever, and phone call us, or however you want to get that ball rolling, and we can provide you with a list of references.
Great, awesome. We got a couple more popping in here. Maybe this was already stated, but what is done if the sediment level is above the gate valve? For example, sand buildup in a manure digester goes above the gate valve. Can this robot still be used?
Yeah, absolutely. A little more challenging, but what will happen is I'll just ask the camera guy to pan to this way towards the gate valve a little bit. I'll walk over the gate valve and explain it. So if we're hooked up to the gate valve and the sediment is up here, basically what happens is as we open this gate valve, liquid's going to try to find least resistance. The liquid's going to start working its way out. If no liquid starts working its way out, we start deploying that robot in and start gravity working some of that sediment. If we know the sediment's above there, we can add a power wash system to this to basically help introduce water to break this sand sediment up. And basically this robot may not come out of this box for 2 days, depending on how much sand above your digester hole you have. But at the end of the day, what we tell people is if you put this on, utilize it. Don't let it get above your hole. I mean, because we can't put this onto an existing digester unless the liquid gets down below. Now we're working on that today to understand how we're going to be able to get these valves onto an existing live digester without draining them. We're, I would say 12 months away from that.
Yeah, within the next year.
Yeah, so that's going to be a possibility in the future. But to answer the customer's question is, don't let it get above the manhole. If it is above manhole, we do have the ability to clean it out. It's not an ideal situation.
Awesome. We have a question that is there a video of the robot in action that we could see event like be sent out later?
Yeah, so we have a YouTube video, but so again, the big thing, and this is asked a lot, I'm backwards. So the water tank that we have, our test tank that our guys operate and test on our system, that is on YouTube, our YouTube channel. However, everybody says, oh, that's just water, and there's only sand in the bottom of it. Well, I asked them, you can't see a robot inside of a sealed digester in manure. It's impossible. Now, if we did that, we would put a video camera on our robot. So, it all depends on what you want to see the robot do. If you want to see the robot running in a lagoon, yeah, we have that video. We just got done doing that. If you want to see the robot running in an open top tank, yeah, we can shoot you that video. You cannot see it deployed into a sealed tank, into a digester. And that is why we shot our video in a water tank, so everybody can see how it goes in the tank, drops the tank, runs the tank. That's on our YouTube channel if you want to take a look at it. If you want to see some other videos of it moving in a lagoon, again, in a lagoon, you can only see the hose moving. You can't see the robot because it's in sludge. So it just all depends on what the customer wants to see it do.
Okay, great. And more questions keep popping in. So this is great, guys. Keep them coming. Is it feasible to navigate around gas or pump mixed digesters with mixing nozzles and piping networks on the floor of the digester?
No, that would be one of them that we would probably have to decline. There's just certain things, I would love to say yes, but I'm in the business of succeeding. That is just going to probably present too many obstacles for us to navigate at this time. We would gladly take a look at it. We've never said, don't send us a blueprint. We'd sign an NDA and look at your blueprint, and we'll tell you exactly what we can clean. Just all depends the layout of those piping.
Great. And you may have already stated this, but where are you pumping the sediment? Is it going into a truck and then deposited somewhere, or are you pumping it into a nearby location of the customer's preference near the digester?
Great question. Yeah, we covered that with our sediment separation trailer. We can't get that sediment separation trailer in this shop. It's 53 foot. But that was what we explained is, our robots pump way too much sediment for the clients to handle it on their own with their screw presses or any sand separation they have for their own process. They can't handle that. So we had to design, patent, and developed was our own sand separation system. Sediment removal trailer is what we call it, but it'll pull out the sand, other foreign debris in your material and send you guys back, the client back, dissolved solids at less than 1%. So you're gonna get your manure and your biologicals back. We're going to separate out the solids. We separate the solids out, and then it's the client or vendor's responsibility to get the solids to wherever they want, land application, bedding, or whatever that looks like. We have the ability to get it basically as dry as you want it. That's an additional cost, but it's another mobile unit that just adds on to our trailer. We have a client right now who wants it 35%. That's a challenge, but it's doable. We have that solution figured out. And again, we're all mobile. We can put this trailer anywhere. But we don't use any polymer, no flocculating, no chemicals. So we don't change anything of your system. We just get the debris out of your system.
Great. All right, we have 3 more questions. So to my attendees, if you have your questions, get them in there. We need to put this gate valve on a live tank with sediment above valve level. Assume this means we have to empty our tank and move some grit around anyway. Any tips or supporting equipment for this install?
Yeah, we actually have done, 10 of those, 10 of those, we call them traditional cleanouts in the last year, because people wanted to get the gate valve on. So what I tell people is, great, either there's two options to get a gate valve on an existing tank right now. A is bring it offline, completely go through maintenance, bearings, anything, bring it offline. We'll clean it out. We have our traditional cleaning fees. I've been doing this for 25 years. I will not do it unless we are doing it a gate valve install. I've gotten out of the traditional cleaning process unless we are installing a gate valve. So we would come in, clean the tank, and get it all ready. You guys would maintenance it, make sure everything's looking good and nice. We would get our gate valve on there, and then not to go back into that tank for years to come, except with the robot. That's one solution A. Solution B, if you have a newer tank, year old, doesn't have much sediment, 2 years old, doesn't have much sediment, still below the manhole, you drain your liquid below the manhole. We just did this for a client, 6 hours from start to finish. They started draining in the morning, got it below the manhole. We got the manhole off, got the valve on, bolted. They started, last bolt was being tightened. They're filling it back up. Within 6 hours, they were back to full capacity. So that's another solution. So you can look at it two different ways. The third, and like Ian and I discussed, within the year, we'll be able to hot tap our valve right in place onto your digester. And it's a little more costly, but it saves you from having to bring it down. So
Awesome. And how often is clean out recommended?
great question. That was one of the questions we get asked a lot. I'm sorry I should have answered that earlier. However, that's a very fluid question. What we do after we put a gate valve on and we start filling it with liquid, we really look at the digester and talk with the operators and who's running that digester on, hey, what percent solids are going in? What percent solids are coming out? Is there any temperature issues going on yet? We start kind of building that plan together with them. You can look at it like, hey, we're only paying for sediment removed, so we want you to come every 6 months. And we'd say, no, we're not coming every 6 months. Annually is pretty much the answer that we're giving people right now. If you're in the food grade world or some other low sediment world, you could probably get by going every other year. But again, we only charge sediment removed in this scenario. We have different rates for like open tanks or in-ground tanks or different things like that. But for that scenario, sediment removed you charge for, and that's it. So it's client's benefit to do it more often than not, I guess.
All right, and our last question for today is what concerns might there be regarding sparking and potential explosions caused by the robotic components?
Yeah, that's great. So as of right now, I believe we're class 1 D2.
Yes.
Yeah, class 1 D2. However, we work below gas line. So when you fill that box full of liquid, we're not concerned, with any sparking issues. We are working on our class 1 D1 so we can get into the chemical and oil world. And then our operators operate out in zone 3, only system that allows our operators to get away from the tank in zone 3. But as we're in zone 1, you have all the liquid coming out of your tank. There may be a little small gas release as you start to open it. That gas that would still be in the liquid, but the amount of liquid entering the box and being present all the time doesn't present us a sparking issue in those scenarios. Now, if you get into, like I said, oil and gas industry, that's a different, you know, different animal because they're not full liquid. There's just some sediment that needs to be removed, and now you have fumes, all that stuff. But that's exactly why we wanted to enter at the bottom of the tank to get away from the gas line. So hopefully that answers your question. If you have other concerns on that, we can dive in with our electrical engineers here on staff and Ian and work through, we have certain protocols, lockout, tagout systems we can do to ensure additional safety concerns or anything like that. But we take safety as obviously our top priority. So any concerns that anybody may or may not have, we can get them addressed.
Awesome. And that was all of our questions. So I'm going to give a brief pause just in case anyone's currently typing. If either of you have any last notes to speak on while we wait for any more questions.
No, I don't think so. Finally, we go across the United States, work in all different states, Canada, Mexico, cross seas, overseas. So if you have something, if you have a project you want to talk about, we're always willing and able to discuss the project. If you want to see it on your system, We work out certain arrangements to make that happen. So we're a very open company. We want to see everybody succeed. I believe in anaerobic digesters. I want to see them succeed. I've found that this is a very big problem that a lot of people try to sweep under the rug on cleaning digesters. So we're trying to be proactive and helping digester companies succeed, and keep growing this industry, because I think it's a very viable solution for the future.
Awesome. Well, thank you guys. It looks like we're all done with questions. So, a huge thank you to Bristola for putting on this webinar. I think it was incredibly informational and helpful. I'm going to be sending out the recording of this presentation along with slides and contact information tomorrow morning in case you want to get in touch with Jared or Ian. And we hope to see you at future ABC events, including Biogas Americas in Chicago this May. And if you need more information on that, you can go to biogasamericas.com. And if that is everything from our guests, Jared and Ian, we will let you go and enjoy the rest of your afternoon.
Thank you, everybody. Thanks for your time. Thank you, Bailey. Thank you, ABC. Appreciate it.
Absolutely. Have a great day, guys.